Something else that you should have become aware of in your POGL activities and by reading the book is that, you know, we've already talked about this, but you can have multiple bonds, multiple carbon bonds. And whenever you have a carbon-carbon double bond, that class of compounds, that class of hydrocarbons containing a carbon-carbon double bond, those are called alkenes. Okay, alkanes are carbon-carbon single bonds. Alkenes are carbon-carbon double bonds. And alkynes are when you have a carbon-carbon triple bond in your hydrocarbons. So the simplest alkene then, of course, is ethene. Ethene, which has a molecular formula of C2H4. The common name is ethylene. Ethylene, very important compound industrially. Propylene or propene is 3 carbons and between two of the carbons there's a double bond. So that would be propylene okay, propene is the IUPAC name. Propylene is the common name. Ethylene is the common name. Ethene is the IUPAC name here. Okay, so you need to know both. This is a very common little molecule. Ethene and ethylene are the same thing, and that's the structural formula of it. Alkynes, the most common alkyne is acetylene. The common name is acetylene. Acetylene. It's just the carbon triple bond with 1 hydrogen on each one. That's acetylene. It's called, the systematic name is ethine. You hardly ever hear that because it's been around for so long and it's called acetylene. It's the fuel, the gas that's used in welder's torch. Because remember, triple bonds are very, very strong. And so when this bond is broken and it's rearranged to give you carbon dioxide and water, a lot of energy is released. So welder's torch is a very hot burn. Burns hotter than, say, ethane or methane. Okay? So that's just multiple bonds and some basic nomenclature there. Should have picked up on. And I mentioned before that carbon, you know, in an alkane, the carbon is saturated with, you know, all the bonds that can have hydrogen on them have hydrogen on them. So as it turns out, you know, carbon tends to form 4 bonds, and that helps us interpret these different structures. Like, for example, the line structure, which is I'm going to show you next. But if you know that the carbon always has 4 bonds, for example, they can have 4 single bonds. It can have 2 single bonds and a double bond to another carbon. It can have 2 single bonds to different things and then a double bond to an oxygen. These are very common ways to find carbon in organic molecules. Or there can be a carbon-carbon triple bond between 2 carbons or a carbon-nitrogen triple bond. So we see these different ways that carbon exists in organic molecules, but the bottom line is that carbon tends to form 4 bonds. If there's a double bond, a carbon-carbon double bond or a carbon-carbon triple bond, we'd say that that hydrocarbon is unsaturated. There's more hydrogens that could have been added to it had it not had a double or triple bond. Okay, so this concept of saturated means saturated with hydrogens, and unsaturated means may have a double or triple bond. And you've probably heard that language before in the context of fats, saturated fats and unsaturated fats. And we'll swing back around to that in Unit 9 when we talk about nutrition, but it's a real important concept.